All right, recording the end of this video, or the end of this section, I should say. So we last left off talking about the ionic equation. And so I want to just mention again that when you have something other than aqueous, so if it's a solid, a liquid, or a gas, that is your precipitate, or that is your product. You don't break that up. You don't separate that because that's not ions. You only are going to break up the aqueous because that's what creates the ions. And so when you think about, okay, the nitrates and the potassiums don't really do anything, right? We called those the spectator ions. So we want to get rid of them. They're not essential in thinking about the chemistry that has happened here. So that's where you get the last equation, which is the net ionic equation. And what this does is it only shows the ions that are involved with making the precipitate. So what I do is real simple. You just, whatever the precipitate is, you just bring that down. And then whatever ions made the precipitate, which should hopefully be easy to identify because they'll be the elements that are in the formula, you just literally bring those down just as they are. All we're doing is just removing the spectator ions. And so that's what the net ionic equation is. And so let's look at an example. So let's take a look at example number 4. What we're asked to do is we're asked to write the molecular equation, the ionic equation, and the net ionic equation, as well as identify what the spectator ions are, and then finally what the beaker drawings would look like. So this is going to be a little bit in depth. There's a lot of things it's asking us, but it's a good opportunity to practice kind of all the things we've learned about precipitation reactions. So let's read what the situation is. An aqueous ionic solution of potassium sulfide is mixed with an aqueous ionic solution of aluminum nitrate. And I'm going to see if I can make this image just a little bigger because I'm going to have to write in there. So let me just expand that. I mean, the font's a little wonky, but I think you'll be okay. Okay, so what we're going to do is we are going to first write the molecular equation. Whoop. And so let me make my pencil a little bit thinner so we got some space there. So remember, the molecular equation is just like me asking, write the chemical equation. It's super important to make sure that when you're writing out the chemicals, write the formulas correctly, because if you don't, it's going to mess up everything, right? So let's take care to make sure that we write everything accurately. So the very first thing that we are told is reacting is an aqueous ionic solution of potassium sulfide, right? So potassium, okay, is K, and then sulfide is just the element sulfur. Now be careful, don't just write Ks, make sure that the charges cancel out to be 0. Potassium is +1, sulfur is -2, and so we'd actually need to make this K2S. And I'm going to rewrite that because that's awful handwriting. Awful handwriting. Let's see if I can make that a little bit clearer. I thought I was going to make the pen a little bit thinner, but it's hard to see. There we go. That's a little better. Okay, and we're told it's aqueous, so I can put the AQ right there. Plus, okay, it's going to mix or react with an aqueous ionic solution of aluminum nitrate. So aluminum is Al, and nitrate is NO3. Okay, aluminum is +3, nitrate's -1. So in order to make this written correctly, you've got to put a parentheses around here and put the 3 on the outside there. And once again, we are told that this is also an aqueous solution. So terrible handwriting, but nevertheless, that's written correctly. Now pause for a second. A lot of students make mistakes. Like I said, they don't write things out correctly. They would have written out aluminum nitrate is just AlNO3. You've got to make sure you write everything accurately. Okay, so let's predict the products. Let's see what we got going on here. So the potassium and the aluminum are going to switch spots. So it doesn't matter what order you write it in. Okay, so let's say the aluminum is going to come over here and bond somehow to the sulfur. Notice all I do is just bring over the elements. Don't bring over the subscripts involved with them because now they're bonding to new things, and so the subscripts might be different. So when aluminum bonds to sulfur, okay, aluminum is +3, sulfur is -2, and so to make this written correctly for aluminum sulfide, you'd have to put Al2S3. Is that going to be a solid or is it going to be aqueous? I don't know. We'll have to check our solubility rules. We'll do that in a second. The second product is potassium is going to come over here and bond to nitrate. So remember, once again, I'm not bringing over any subscripts. So I'm just going to say, hey, potassium is going to somehow bond to nitrate. The 3 is fine because that's part of nitrate. Potassium is +1, nitrate's -1, so that's written correctly. Let me leave a little parentheses there because I don't know what the states of matter are. So to figure those out, we're going to consult our solubility rules. And so let me actually get a larger one here. So the first one is aluminum bonded to sulfur. So sulfide containing ions, when they are bonded, are going to be insoluble or solid. And aluminum, notice, is not an exception. So that was nice and quick. We identified what our precipitate was very quickly. And if we take a look at the second product there, that one's going to be aqueous. Hopefully you spot that quickly because of the potassium. Last thing we need to do is we just need to balance. So let's do that real quickly here. I see a 2-3 ratio here, so that tells me something is going to be 6, right? So I'm going to keep that in mind. So if I look at over here, the nitrates, okay, I have 3 nitrates on this side, 1 nitrate on this side, but I know I'm going to end up having that 2-3 ratio, which is going to be a multiple of 6. And so however you do the balancing at this point, honestly, is up to you. Okay, but we're going to end up having a 6 there, a 3 here. We're going to need a 2 here, and then let's see. No, I'm sorry. The 2 is right here. There we go. That looks a little better. Put that arrow back in. Okay. So that's our balanced chemical equation, 3, 2, 1, and 6. Like I said, the molecular equation is the hardest part. If you can do the molecular equation and spend some time making sure everything's written correctly, everything else is pretty straightforward, very simple. So now that we have that written correctly, let's go down and write the ionic equation, or total ionic equation. Remember, everything that is aqueous needs to be broken up into ions. So that would be these 3 compounds right here. Remember to have the correct number or the correct quantity as well as the correct charge, right? And so the first ion is the potassium ion. How many do we have here? Well, total we have 6 because the 3 and the 2 both get taken into account. So we have 6 potassiums. Potassium has a +1 charge. And then make sure you write aqueous because that's what it's an ion. It's aqueous. Plus, our next ion is the sulfur ion. There's going to be 3 sulfur ions because of the 3 out front. Sulfur is a -2, and that's also aqueous. All right, so now that was our first reactant. Let's look at our second reactant. The second reactant, what ions do we have here? We have 2 aluminum ions. That's going to be 3 plus, well, aqueous there, plus the nitrates. You have the 2 out in front, and you also have the 3 on the outside, so total we have 6 nitrates. All right, so there's all of our reactants. And then on our product side, the solid, I'm not going to break that apart. I want to leave that together. So Al2S3, I'm going to leave that as a solid. And then plus, so this last piece here is aqueous, so we're going to break that up. 6 potassiums and 6 nitrates. All right, and that's aqueous. So it's not difficult. It's just there's a lot of little pieces that you just need to make sure that you don't leave out. Now, when you go down to the net ionic equation, this is where you are only going to write what ions were needed to make the solid. And remember, the solid, I'm just going to pull that down, was Al2S3, and that's my solid. So what ions were needed to make that? Well, the 2 aluminums right here. Okay, so 2Al3 plus, and that's aqueous, plus these 3 sulfur, or sulfide ions, I should say. All right, so that's our net ionic equation. So all of these, the potassiums and the nitrates, notice they didn't do anything. Those were your spectator ions. So when it calls out or asks you to identify what the spectator ions are, it was the potassium ion and the nitrate ion. You don't have to put the numbers because it's just asking what the ions are. Now, there's a really nice trick or shortcut to figure out what the spectator ions are going to be. If I were to give you on an exam a molecular equation, and I asked you real quickly, identify what the spectator ions are going to be. Here's an easy trick. On the product side, anything that's aqueous, it's those ions that are going to be spectator. So I could have figured out potassium and nitrate were the spectator ions easily by just looking at that. So that's a trick you can use. Okay. For as far as the beaker drawings, that's just simply drawing everything out in ion form. So the first beaker represents the first reactant right here. And so we already have those written up here. We just need to bring them down to the beaker. So you get your 6 potassiums, and then we have our 3 sulfides. Notice I don't have to put aqueous here because when they're in the beaker drawings, it's assumed to be dissolved in water. The second beaker represents the second reactant, which was the aluminum nitrate. So those 2 aluminums that I had here, and those 6 nitrates, I just pull down and I just draw them in the beaker, just like that. And then in the final beaker, that's just basically saying, hey, once you mix those, what do you create? So the first thing you create is the solid, which we know is Al2S3. And then your spectator ions are above, those 6 potassiums and then those 6 nitrates. Those are going to go right above, just like that. And that's it. That's how you write out your different types of equations. To end this video, we're ending with the 6th and final type of equation, or chemical reaction, I should say, and that's the acid-base neutralization. An acid-base neutralization reaction is also double replacement, but it's specific. And you've probably guessed, it's between an acid and a base. How do you know if you have an acid or a base? You are looking at their formula, okay, and you're looking at acids, remember, have the beginning of hydrogen. They'll need to be in the aqueous form. And then bases, a lot of bases have hydroxide in the formula. Not all of them, but a lot of them do, especially strong bases. And what do they produce? They always are going to produce water and then some sort of salt. Remember, salt is the general name for any ionic compound. So that's what an acid-base neutralization reaction is. So it's still double replacement, but it's more specific. If you take a look down here at what would that total ionic equation look like? Well, you'd break everything up into ions, just like what we saw before. So you have your hydrogen ion, your chloride ion, your sodium ion, and your hydroxide ion. And then on the right side, what do you produce? Well, water is your precipitate in this case. It's not solid, but that's your product. You make water. The sodium and the chlorine are still in ion form. So those are your spectator ions. And I could have guessed that because on the product side, those are the 2 that are in the aqueous form. So when I ask you to write your net ionic equation, look what the net ionic equation is going to be in your acid-base neutralization. It's the hydrogen ion and the hydroxide ion creating water. All right. This is examples 5 and 6. We're not going to go over that in the video, but that's something you can do in your notes so you can see and get some practice identifying types of reactions as well as predicting products. Make sure that you spend some time knowing how to predict products, meaning I give you the reactants and then you have to predict what the products would be. If you need any help with that, you can look at worksheets that I have in Canvas. You can also Google additional worksheets, Google predicting products for chemical reactions. If you still need help, you can always reach out to me. I'll see you in the next video where we start section 4.